Okay, let's have example 5.5 from your handouts. For the fixed-ended beam shown, EI is constant. Determine the nodal displacements, member forces. So we have 5 degrees of freedom for this beam, one at B, one at C, another one at D, rotations B, C, and D. Then we have displacement and rotation at E. So that makes it 5. But we can reduce this to 3 so that you can use your calculator by disregarding DE first, but we only consider the moment produced, which is 30 times 3. So it should be counterclockwise for DE. So these are the moment effects of the loads, fixed moments, and forces, reactions. We remember that each node is considered fixed, although it's not here, it's continuous. So remember the principle of fixed moments. So we have counterclockwise moment at DE of 30 times 3, so 90. It's there. So for fixed moment AB, because we have a varying load here, we consider a strip. Let's call the distance from this 24 loading to that strip as X, and divide the loading into two parts, rectangle and triangle. But we consider this as a whole trapezoid. So that 36 minus 24 is 12. 12 divided by 6 is 2. So the height of the strip is 24, because this is already 24 plus 2x, where 2x is 36 minus 24, 12. The height of the triangle, 12 divided by 6, 2. So times x, 2x. So 24 plus 2x would be the height of that strip. So the distance of that strip from left, A, is 6 minus x. Its distance from the right is x plus 2. For this strip here, if we denote x as distance of the centroid of strip from the zero load as x, then 27 divided by 4.5 times x, that would be the height. 27 over 4.5 of x, so 6x the height. So fixed moment AB equals integral 0 to 6 of quantity 24 plus 2x dx times 6 minus x times quantity x plus 2 square over L square 8 square. So fixed moment AB is 151.65 kilonewton meter. For BA, we use the same integral. This time 6 minus x is squared, x plus 2 is not. So 6 minus x squared, x plus 2 over 8 square dx. So that would be 109.35 kilonewton meter. Then for FA, summation moment sub B, FA times 8 plus 109.35 equals 151.65 plus moment of the, we divide this into two triangles. So 1/2 of 6 times 36, moment arm is 4 plus 2, so 6. Then plus 1/2 of 6 times 24, moment arm is 2 plus 2, so 4. So FA is 9783 over 80 kilonewton. Summation forces Y equals 0. FBL plus FA equals area of the trapezoid 1/2 36 plus 24 times 6. So FBL is equal to 4617 over 80 kilonewtons. Then for portion BC, fixed moment BC equals integral of 6x dx times quantity 2 plus x times 6 minus x quantity square divided by 8 square, where the distance of the strip from the right is 6, because this is total 6, minus x. So 6 minus x square over 8 square. So fixed moment BC is equal to 6561 over 160 kilonewton meter. Fixed moment CB is same integral, 2 plus x is squared this time, 6 minus x is not, 0 to 4.5 again. So we will get fixed moment CB equals 64.357 kilonewton meter. Then for FBR, summation moment at C equals 0. FBR plus 64.357 equals 6561 over 160 plus 1 half of 4.5 times 27 times 3. Centroid 1.5 plus 1.5 is 3. So FBR is equal to 19.862 kilonewtons. Then summation forces Y equals 0. FC left plus FBR 19.862 equals 1 half of 4.5 times 27. FCL is equal to 40.888 kilonewtons. Then fixed moment CD. Fixed moment CD is equal to 30 times 2 times 3 square over 5 square plus 42 times 4 times 1 square over 5 square. So fixed moment CD is equal to 28.32 kilonewton meter. Fixed moment DC is 30 times 2 square times 3 over 5 square plus 42 times 4 square times 1 over 5 square. So fixed moment DC is equal to 41.28 kilonewton meter. For FCR, summation moment B equals 0. FCR times 5 plus 41.28 equals 28.32 plus 30 times 3 plus 42 times 1. So FCR is equal to 23.808 kilonewtons. Summation forces Y equals 0. FDL plus 23.808 equals 30 plus 42. So FDL is 48.192 kilonewtons. So take note that we end at D because if we continue, this will be 5 by 5 and we are forced to use Excel for that case. But this is intended for your quiz or for your exam, so that's why it should be, you should have the technique on how to reduce it to 3 by 3. So we stop at D, but remember the moment at D due to this 30 kilonewton is 90. So for the nodal forces, so fixed moment BA is 109.35 minus fixed moment BC is 6561 over 160. The result is positive, so it is positive 2187 over 32 for node 2. Node 1 is not important because that's fixed. For node 3, fixed moment CD, which is 64.357 minus fixed moment CD, which is 28.32. The result is positive and it is equal to 36.037. For node 4, it is fixed moment DC, which is 41.28 minus 90, because we have moment here due to the 30 kilonewton. Node 90, so negative, so it should be clockwise. Clockwise at 4. So 48.72. But this is negative when we have the global forces. So we have 3 by 3 because we reduce it to 3 by 3. Important nodes are 4 or U4, U6, and U8. So first we have the stiffness of member AB, which is EI is constant, so 12 times 1 over 8 cubed, which is, the first is 3 over 128, and if you have mastered filling up these cells, also I just copied the cell in the previous examples where we have 3 over 128 for the first step, or when the span is 8 and EI is constant. So this will be the result. KBC is, the span is also 8, so it looks the same as this except the numbering, which is 3, 4, 5, 6. 3, 4, 5, 6, 3, 4, 5, 6. So they are equal. Then for CD, the span is 5, and we already have this. We already experienced where a span is 5. The first entry is 12 over 5 cubed, so 12 over 125. And by experience, we already have this also. Then try to verify that these are the different elements of that stiffness. So global forces, we consider only U4, U6, and U8, and here it is. So for this cell here, 4, 4, 4, 4, we have 1 half and another 1 half. So 1 half plus 1 half equals 1. 4, 6, 4, 6, 1 fourth. We only have 1, so 1 fourth. So 6, 4 is also 1 fourth. Then we have 4, 8. 4, 8 is done when the distance is 4 or greater than 4, it's 0, because 4, 8 minus 4 is 4. There's no adjacent nodes for that case. So 0, 8, 4 is also 0. Then this is 6, 6. 6, 6 is 1 half and 4.4 over 5. So 1 half plus 4 over 5 is 1.3. Then this is 6, 8. 6, 8 is 2 fifths. So 2 fifths. 8, 6 is also 2 fifths. And finally 8, 8 is 4 fifths. So U4, U6, U8 can now be solved, which is the inverse of this 3 by 3 matrix times this global force matrix. The global forces, 2187 over 32 counterclockwise, so it's positive there. Then counterclockwise, 36.037 positive there. Then clockwise, negative 48.72. So U4, U6, U8 equals the inverse of that 3 by 3 matrix times the force matrix. And you will get U4, U6, U8 equals 57.90735 over EI, 41.74560 over EI, and negative 81.772 over 80 EI, which corresponds to theta B, theta C, and theta D. So having found these global displacements, global or nodal displacements, we now compute member forces, which is stiffness, then we have displacement, then fixed end force. So for member AB, these are the stiffness, and only U4 has a value. U1, U2, U3 are all zeros. When you look at the beam, and because U1, U2, U3 are all zeros, columns 1, 2, and 3 are shaded, so that only column 4 is active. And these are the fixed end forces. I hope you already know this because of our detailed examples from previous slides. So, and you know already how to obtain these values here. So you just verify. Then member forces of BC, the stiffness 3, 4, 5, 6. Then only 4 and U4 and U6 are values here. That's why we shade 3 and 5. Columns 3 and 5, 4 and 6 are active. And these are the fixed end forces, corresponding fixed end forces. So I will not explain it anymore to shorten our time, because we already experienced how to compute that. And finally, for member CD, stiffnesses, then only 6 and 8 columns are values because we only have U6 and U8 also. And I hope you know already how to compute that. And this checks our result for moment BC, which is negative 90. Now, let's incorporate DE, because we want also to compute the displacement at E and at T. So we have 7, 8, 9, 10, and the first entry is 12 over 3 cubed. That's why you have 4 over 9, and this is 6 over 3 square. So we have 2/3 negative of 4 over 9, then copy 2/3, then copy 2/3 here. This is 4 over 3, 4 EI over L, so 4 times 1 over 3, 4/3. Negative of 2/3 here, then half of 4/3 is 2/3 here. The negatives of this row here, this is here. Then copy this second row here, which is here, but don't forget to interchange columns 2 and 4 entries. system. Then, considering DE, we have uh, we consider DE. These are the forces. Uh, Remember that there will be no fixed moments in DE because the load is at the end, and the end is imagined to be fixed. So only the reaction at that end will have a value which is upward. That's the fixed force. So therefore, the nodal force is negative 30 at the end. The rest 0. Then because U7 is 0, U8 is already computed, negative 81.77280 over EI. U9 and U10 are unknowns. Then to solve for U9 and U10, then we have to expand rows 9 and 10. If we call this row 9 and row 10, then we have to expand that. Actually, we can also expand the upper two rows because they are also associated with U9 and U10. But to make it clear, you just expand rows 9 and 10. So as I said, you may expand the first two rows instead, except rows 9 and 10. So, but instead we expand rows 9 and 10 because the negative 30 is involved there. But it doesn't mean that even if we do not involve this negative 30, we will not get the same correct answer. We will get the same correct answer. You try expanding the first upper rows instead. So negative 30, 0 equals this 2 by 2 matrix here, rapid times the displacement matrix 0 and negative 81.7728 plus these two last 2 by 2 matrix multiply this U9 and U10 entries for that 2 by 1 matrix. So the first force value would be negative 4 over 9 times 0. Negative 2/3 of negative 81.7728 is positive. So transpose it to the left, it becomes negative. So this is now negative 30 minus 2/3 times 81.7728. And the second entry here is, because this is 2/3 times 0 is 0, 2/3 times negative 81.7728 is negative. Transpose it to the left, it becomes positive. So 0 becomes 2/3 of 81.7728. Then equals this product of this matrix, the second term. Then, because this is just 2 by 2, you can easily obtain U9 and U10 as the inverse of this 2 by 2 matrix times this first matrix. So, solving that right away using your calculator, you'll get negative 515.3184 over EI and negative 216.7728 over EI. So, U9 corresponds to delta E and U10 corresponds to theta. Then, for the member force of DE, so we have the stiffness of DE, the displacement. So we only consider column 7 to be shaded. 8, 9, and 10 are active because we have displacements for 8, 9, and 10. The fixed forces, remember there's no fixed force at the left because the reaction there is 0. At the right, where the 30 kilonewton load is acting, so we have a reaction, upward reaction of 30. That's why it's 30. There are no fixed moments, which I already presented in the previous slides for the overhang. So that's the meaning. So for the first entry, 2/3 times negative 81.77280 plus negative 4 over 9 times negative 515.3184 plus 2/3 times negative 216.7728 plus 0 equals 30. Then try to verify the rest. So actually, because at the overhanging end, there should be no shear, no moment at the overhanging end. So that checks our answer. So moment at A is equal to the negative of 166.127. The explanation were made already in the previous examples. We have plenty of examples before. So RB is the sum of shear just to the left, 52.284, and shear just to the right, 29.204, so 81.488. MB is the negative of MBC, so negative 80.396. R sub C is shear just to the left, 31.546, plus shear just to the right, 14.21. MC is negative 29.007, the negative of this value. And R sub D is shear just to the left, 57.799, plus shear just to the right, which is 30, so 87.799. MD is of course negative 90, this one, or the negative of this moment DE. Then that's it. ME is 0.